Alright, what I ended up doing, I put a plastic rotor on. This is actually PVC, and it's 1 inch, it's about 2-inch thick, it's solid, very heavy, so it's great for a rotor design. I ended up doing is taping 2 magnets. Pretty much that's what I ended up doing, using electrical tape, then masking tape, then electrical tape again to make it pretty solid, and they're not going anywhere. Pretty much the design will actually be traveling every 90 degrees is when we're going to pulse it. So basically at the high voltage discharge, I'm telling you, you're going to have like a railgun effect. That thing's going to just shoot across to the next field rapidly. Right now I just have a 12 volts power just to show you the concept. So I'll just touch the wire right here. Here we go. Oh. There we go. And you can see we already went to 90 degrees, no problem at all. But just imagine when you have a couple hundred joules of energy to discharge on this. Now this is actually very hard to turn, by the way, because it is turning a permanent magnet shaft down in this stepper motor, and that's really long. I'll show you what it looks like. Pretty much it looks identical to like this. Let's see if I can pull this out and show you. You can see all the magnets in there, so it is pretty impressive when you really look at it. Let's see if I get this down. Yeah, I have to get that one out. I started pressing it into the bearing, so I'll end up getting that out. But it's really heavy duty magnets on that. I got a little mess, but that's okay. That's what happens when you build stuff. So pretty much, like I said, this is actually going to do pretty good. Now, every time I pulse this, a lot of people don't understand the back EMF. The back EMF, typically, they use a diode, and they don't actually ground it out like people think they do. What they actually do, they feed that back EMF back into the coil. That gives that extra kick, but it's not an extra kick, because what happens is you're actually increasing the amps also. So when you put that diode back onto the coil, you actually will increase the amps. We don't want to do that. So all we want to do is discharge this coil, cause this to rotate in such a way, and then we'll be able to, that spark right there is what back EMF is, as you can see. And if show you a little quick demonstration. When I touch it, you won't see it spark, but when I pull it away, you will. So when I touch it, it doesn't spark. Pull it away, you do. That's the back EMF that people talk about. They just don't realize what's really going on. It's like a pressure hose. You're putting pressure in that, and then as soon as you turn off the power, you release it, so it's like popping back like a balloon. So you're basically trying to pop all that energy back into the system, and that's basically what's going on with back EMF. So on this particular design, what we're going to end up doing, we're talking some very high voltages, probably even into the hundreds, and a lot of joules. I'm looking at probably about anywhere between 400 joules of energy to discharge on this. And that effect is pretty impressive, because you're going to really slam this around. Now, I don't know if these magnets will withstand that kind of energy in general, but I might have to go with a center rotor and actually have electromagnets in here. If I can find another set of these, I'll end up putting it on a rotor. And that's basically how electric motor works, even with when you're dealing with big electric DC motors. The permanent magnets itself, everyone wants to go for these neodymiums, and that's fine, but always remember, heat will actually destroy those magnets. So the hotter they get, the more weaker they get. That's why they use coils. And that way the hysteresis and eddy's current, you can at least be able to compensate that. But when you're destroying the magnet itself and the saturation, you can actually weaken a magnet pretty easy if you overdo it. So permanent magnets are good only for small things, but when it comes to real motors, most of the time you're going to find that they're coils. So that's pretty much what the update is. I end up just playing around, as you can see, we get a pretty good kick, and this is a load. I mean, look how hard it is just to turn to keep it going. So you do get a good kick, and basically I'm energizing this one and this one, and it causes it to push on both sides. So that's pretty much what we got going on here, and this simplicity of a basically it's an impulse pulse motor, because we're going to capture a lot of back EMF on this design. Talk to you later.